morning to one and all. In the last class we have discussed or derived half-life period for first order as well as zero order reaction. Now we will continue. There is a relationship between half-life period and order of a reaction. In general, order of a reaction is taken as n and half-life is taken as t half. Hence, half-life period is inversely proportional to nth power, that means n minus 1. This type of relation. If suppose n value is 1, that becomes a raised to 0. A raised to 1 is a raised to 0 means it becomes 1. Hence, you can say that n value is 0, a raised to minus 1. It means T half is directly proportional to initial concentration. N value is 1, a raised to 0. It is independent of initial concentration. If n is 2, that means it is 1 divided by a raised to 1, inversely proportional to initial concentration. In general, that relation is T half is proportional to 1 divided by a raised to n minus 1. You go on changing the value of n, you have to finally derived 0 and first order reactions are concluded. At two different concentrations, those concentrations are taken as A1 and A2, and two different half-lives T1 and T2. The relation is given as T1 is proportional to, T1 means it is half-life period, proportional to 1 divided by A1 raised to n minus 1, and T2 is proportional to 1 divided by A2 raised to n minus 1, or T1 divided by T2 is proportional to A2 divided by A1. The common is n minus 1. That means T2 is inversely proportional to A2, T1 is inversely proportional to A1. That means half-life they are inversely proportional to initial concentration. Taking log on both sides. Log on both sides. That is log T1 divided by T2 is equals to m raised to n form, n minus 1 log A2 divided by A1. So, this is of, again you can say that some problems solving formulas. Up to this, we have taken some application or derived form of zero order, first order as well as half-life period, definition, formula, relation with order of a reaction. Now let us discuss an important concept. That concept is said to be collision theory. Concept is collision theory. What is this term collision theory? Just I will explain about the collision theory. If you take a reaction, a chemical reaction, that reaction is containing the number of reacting species. Number of reacting species. Don't you judge that all the reacting species are having the same type of kinetic energy. Like, I will take one example. If I will take a class, one class, that class is containing a number of students. Those number of students are not having the same capacity to understand the subject. Like that, in a reaction mixture, all the reacting species, they are nothing but undergoing effective collisions, but the collisions are not the same. The collisions among the reacting species are said to be different. Hence, I will take for this collision theory some of few important definitions. Those definitions first be understood. After that, what is the collision theory, how it is explained by one equation called as Arrhenius equation. This theory is also known as Arrhenius collision theory. So, some definitions. First one is threshold energy. threshold energy. It is denoted by various type of symbols. I will take the symbol as E naught. How can you define this threshold energy? In a chemical reaction, to make, in order to make collisions effectively, the reacting species must have certain minimum energy. This energy is known as threshold energy. Okay. Suppose the energy of reacting species is less than threshold energy, there is no product formation. Remember that energy of reacting species is less than threshold energy. Suppose I will take energy of reacting species is E. Its energy is less than E naught. E naught means threshold energy. Then there is no product of formation. The meaning of threshold energy, may you quote that meaning as any of the reacting species if they undergo effective collisions. Those effective collisions must be needed some amount of energy, certain amount of energy. If there is certain amount of energy, then only effective collisions takes place. Such type of energy, certain minimum amount of energy possessed by reacting species in undergo effective collisions, that is called as threshold energy. Okay, threshold energy meaning is said to be the reacting species must have certain minimum energy to undergo effective collision. Okay, if energy of that reacting species is less than threshold energy, you can say that there is no possibility of product of formation. The similar way, second definition, the definition is said to be activation energy. It is denoted by the symbol as EA. It is defined into different way. First one is the reacting species. Have minimum extra energy. In order to undergo effective collisions. Okay. Which kind of molecules are having minimum extra energy possessed by the reacting molecules in order to undergo effective collisions, that is called as energy of activation. Okay. In another form it can be defined as or. The reacting species forming intermediate. An intermediate called as activated complex. The energy is known as activation energy. Okay. First type of definition. Which reacting species must have minimum extra energy to undergo effective collision? That energy is activation energy. Or another form is which reacting species they are responsible for forming an intermediate. That intermediate is known as activated complex. The energy is known as activation energy. The term intermediate or activated complex is appeared very short time and it undergoes unstable or breaking of bonds forming a product. So this I will explain in detail by taking graphical representation, that is activation energy. Okay. In the classroom there are three types of students. I will divide. Type student A, they are having the energy as threshold energy. They are needed to understand only one class. Second type of students group, that is B, they are needed one more class to understand the subject. That one class needed is called as threshold energy. The same subject, if the students needed two classes are said to be, it is activation energy. And third type of students, they are said to be, again they needed one more class. That type of students are called as most probable kinetic energy. Most probable kinetic energy. So all these I will explain with the help of graph. This most probable kinetic energy meaning is the kinetic energy possessed by maximum fraction of molecules in the reaction mixture. Okay. Most probable kinetic energy. Kinetic energy possessed by maximum fraction of molecules in the reaction mixture. This we understood clearly, that which are in nearer to passing, if we will give work more and more, definitely those number of students are acquiring maximum kinetic energy to pass the result. That means they are maximum students. Suppose 20 students are there. Those 20 students I will take repeated time classes. Definitely they achieve the passing level. So such are said to be reacting species are converted into product. Okay. These three types of energies, just I will represent or explain the type of energies by equation. That equation is called as Arrhenius equation. This Arrhenius equation is for the collision of reacting species. The equation is represented as K is equals to A into e raised to minus EA divided by RT. K is equals to A into e raised to minus EA divided by R into T, where K is rate constant, A frequency factor or Arrhenius factor or pre-exponential factor. EA activation energy, and T temperature, this is very important, R gas constant. In this Arrhenius equation, dependence on T is there. How rate is depends on temperature. That again I will represent by one definition. The definition is called as temperature coefficient. Definition: for a chemical reaction with rise in temperature, by 10 degree, the rate constant is nearly double. What this the meaning indicates? According to Arrhenius theory, Arrhenius equation, rate is dependence on temperature. That can be explained by temperature coefficient. Temperature coefficient is for a chemical reaction with rising temperature. How we are rising the temperature? 10 degree rise in temperature. The rate constant is nearly doubles. Or temperature coefficient is equal to rate constant at T plus 10 degree to rate constant at T degree. Its value is nearly 2 times or 3 times. How can we define temperature coefficient mathematically? It is the ratio of rate constant at T plus 10 degree to rate constant at T degree. That means for every 10 degree rise in temperature, rate constant is nearly 2 or 3 times. Doubles or sometimes it is triples. So this is Arrhenius equation. ಇದನ್ನ ನಾನು ಗ್ರಾಫಿಕಲ್ ಆಗಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡು ಇನ್ ಡೀಟೇಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಇನ್ ದಟ್ ಕೇಸ್ how collision is taking place, activated complex is formed, and what is the effect 10 degree rise in temperature, rate is doubles. We will represent graphically.